Uh, are you able to hear me? Okay. Good morning. How are you all doing? Good, good. Okay. Yeah, I was at Reinforce yesterday. I just flew back yesterday night to attend this event. Yeah, thank you all for coming. What a day to start with the previous keynote where we talked about solving real life problems with machine learning. There is just so much happening in machine learning nowadays. Applications used to take years to build or being built over weekend during weekend hackathons. Generative AI has become a buzzword recently. Everybody is talking about generative AI. Here at AWS, we believe generative AI can reinvent every customer applications and interactions. My name is Suresh Poopandi. I'm a senior solutions architect with AWS based in Chicago. I've been with AWS for 4 years, helping healthcare life science customers with their cloud journey. I'm here with my colleague.
Hi, everyone. Good morning. My name is Alak, and I'm a senior solutions architect here at AWS. I've been with AWS for about 3 years, and I support digital native business customers in the US Central. And I've been based in Chicago as well, and very passionate about machine learning and artificial intelligence. Very excited to be here with you all today.
Okay, here is the agenda for today. I'll start with giving an introduction about generative AI, and then what is the foundation model, and then what and why. And then Alak will cover the AWS services and tools available to help you to get started with Gen AI. And she will also share some of the resources you can use to get started your generative AI journey. Given that, let's get started. Machine learning is at an inflection point. What do we mean by that? Machine learning have existed for decades, but with recent steadily available, ready and scalable compute capacity increases, and then large growth of data, and then advancements in ML techniques have led our customers to use machine learning to transform their business, and then. Generative AI has captured everyone's attention and imaginations. So we believe generative AI is going to transform every business. And then we look at what is generative AI. Okay, generative AI is like any other AI. It's powered by a machine learning model, but it's powered by a large machine learning model called foundation models. Generative AI can create original content and ideas, including audio, video, story, images, and conversations. So when we talked about foundation model, how that is different from the regular machine learning models, I would say there are 3 key advantages of three differences between the regular machine learning models and foundation models. One is the number of parameters supported are used by the foundation models. So you can think the parameters is equivalent to the model sophistications. So the larger the number of parameters it supports, it starts exhibiting some behaviors that is not known before. So in 2019, the state of the art machine learning algorithm supported 330 million parameters. In 2021, it went to it's become 175 billion, and then 2022 it became 540 billion. That is like 1,600 times increase in just 3 years. Also, along with this number of parameters increase, there are a couple more innovations that's helped in the foundation model. One is in-context learning. I'll just cover that in the couple of slides after. And then the other one is the other one is the number of parameters we looked at it. Let's look at where does the generative AI fit in. AI is like a way to represent any system that needs that can replicate the task that requires a human intelligence. Like in the previous example, we are trying to predict something. So similar to that, AI is try to predict something with a high confidence. Most of the AI use cases will be predicting some kind of use cases with high confidence. Within that, almost all AI systems are implemented using machine learning. Machine learning is a technique that uses a large data set to come up with the decision logic or decision tree that's called model. Within that machine learning, some of the models are deep learning models that employs a deep neural network, that's a multi-layered neural networks that can do complex logic similar to how the human brain works. So it can do speech and image recognitions. Within that, like our generative AI comes in. Generative AI are usually powered by large models. Those are trained on a vast corpus of data. That's also commonly referred as foundation models. Okay. So these are some of the use cases for generative AI. I think everybody knows about the text generation. So you can give a prompt and then it can give a blog or story or conversations and other stuff. Code generations, like that's getting famous among the developers. You can just give a couple of comments in the code, or you can give a prompt and then it'll create a code segment for you. And then on the image generation, like you can say, hey, I want to generate an image of astronaut riding on a moon, so it can generate an image. So based on the prompt, it can generate images and much more, a lot of other use cases. Let's look at the use cases from an industry perspective. Since I support healthcare life science customers, I'll talk with the healthcare. It can, it changed the way, how life science customers do a protein folding analysis and then the drug development. And it also sped up the personalized medicine. The personalized medicines, we generate a medicine based on the human DNA and other biomarkers that improve the way how improve the speed of the personalized medicine generation. On the medical imaging side, recently a study was published to develop a 3D view of organization, 3D view of the organs based on all the 2D X-ray images. That helps physicians to diagnose diseases quickly, and a lot of other use cases like that. Okay. Let's look at some of the real life, already real production use cases for text. On the Cohere and AI21 Labs Vatune, it's a text, so you can give a prompt, it's a text summarization. So it saves you time in reading like entire paragraph. It'll give a gist of the paragraph. You can give a blog or a story and then it'll give a gist what the story is trying to tell you. And then on the AI21 Lab Vatune, it helps you in writing an email or composing a statement. You can choose, what kind of tone you want that message has to be. So it will come up with that, writing for you. This is, image example generated by the Stable Diffusion 2.0. For this image, we gave the photo of a living room, and then the furniture was not there before. We asked the model to add the furniture. And then when it added the furniture, it can account for the sun rays coming in, sunlight coming in, and then creating the shadows and other stuff. And then on the right side top, if you see, like we asked, model to put together glasses on the persons, it can account for the 3D depth, and then it can properly put a specs on those images. And on the upscaling side, like it can also upscale the images up to 4 times. So that's going to help, like, all the photos taken 10, 20 years ago, it was like a grainy, that can be upscaled to a bright looking, images. Let's look at one more example of the clothing design. LG created this Exxon foundation model that's used for creating a clothing design based on a set of images. So before this image, it used to take 9 months for them to come up with a clothing design. After this, with this image, they're able to reduce the time taken to generate a new design to 1 month. So it's basically reduced it from 9 months to 1 month. And then this model was built using SageMaker distributed training to build this model. It was built on large data, so it took some time for them to build this model, but it reduced the time from 9 months to 1 month. Let's look at, why foundation model, what's the difference? In the traditional model, I think like the previous use case, we look at the label data. So for example, for the bike, so we look at the weather data and then the bike data, and then choose a machine learning model that's appropriate for that label, for the use case. Like if it's a text generation use case, we'll try to pick a model that's appropriate for the text generation, and then identify the corresponding data, and then train the model, and then deploy the model to perform a specific task like text summarization or information extraction and etc. On the foundation, on the generative AI use case in the foundation model, we are going to feed the foundation model with like all data, like it can be structured, unstructured, and then it's going to be unlabeled data. You don't need to say, oh, this is a weather data, this is a bike data. So you're going to give all the data into the foundation model, and then the foundation model is going to learn that. And then it can be easily adopted to do any type of broad range of tasks. So you have to give, as part of invoking the model, you are going to give a prompt saying that, hey, I want this output. So the model can customize, adapt to that requirement, and then generate it. I'll just quickly touch on those three ML techniques that helped to the rise of this foundation models. One is the in-context learning. In the traditional ML model, so once you build the model, you have to retrain the model with another set of label data to keep it up to date. But in the foundation model case, when you query or when you request the foundation model, you can provide some sample input, like, this is an example, and then it can use that example to train as part of the inference itself. Like so it's a in-context learning. So it can learn with a very minimal compute power, with minimal data, it can learn as part of the task itself. And then the second, we talked about the number of parameters increase. So it's going to, based on the unlabeled data, it's going, the number of parameters are high. That's the main difference between foundation model and the ML models. And let's look at, and the third one is the transformer-based architecture. So the invention of the transformer-based architecture is really helpful on the FM side. So with the transformer-based architecture, it's easy to scale and then do the parallel load, training of the model, parallel load. And also it's easy to model the interdependence between the input and an output. Let's move on to how it works. So we're going to take unlabeled data. It can be a video, audio, text, any of the models, any of the data, and then load that into foundation model. And then it can be easily adapted to do a broad range of tasks. So let's look at some of the foundation model categories. One is a text to text that like everybody is aware of that. Basically, you can give a prompt to generate a story or prompt to generate a blog and other stuff. Also, you can do a text extraction, text summarization. Those all will fall under the text to text foundation model. And then the second category is a text to embedding. That will be used in searching a context, searching for a words. Like for example, like some user types a word in a search box, and then the text embedding model will convert that to a numerical representation, and then that numerical representation can be used against to search against the corporate proprietary databases. And then the third one is a multimodal. The stable diffusion is one of the examples. And so that model can handle video, audio, and then it can also generate video, audio, and images and videos and audios based on the prompts. Those are multimodal examples. Okay. So let's talk about some of the challenges with this current foundation models. So we classify the foundation models into like these three categories. One of them is the proprietary models. Those are models owned by a corporate, and then that's like given access to end users using an API. And then the other one is a publicly available models. So like those like free to use, but you can most of the models will be available in Hugging Face will be foundation model, publicly available models. So you can get that and then use that in your AWS account and other stuff. Third one is building your own models from scratch. So what are the challenges with those? So in the proprietary model, you don't know how your data is going to be used, correct? Like you don't have a control over how your data is going to be used for the training that foundation models. And then how can you customize that? So because if it is available on API, do you have a capability to customize that? And then how secure your data is going to be when you use a proprietary model. And then if you look at the second one, the publicly available models, you need to do some substantial undifferentiated work to take the model and then deploy that into some compute environment and then make it productionalize it. The last one is a more challenging one. So you have to build your own model. So you have to collect the data from various sources and then make it available. And then you need to have a deep expertise in the machine learning to do it. So I talked about the in-context learning. So here's one quick little bit more detail about the in-context learning. So we are going to give a prompt to the large language model to get an output. So this will be a prompt structure. And within the prompt, we're going to say, hey, I want to do this task. This example is saying, this is a movie review. It can also correct the spelling mistakes within the task, right? Like you were saying, this is a movie review, but the model understands there's a typo in the task description. And then you don't need to give an example. You can just say, hey, I want a movie review, and then I enjoyed this movie. It can come back with an answer. So if you don't give any example, that's called zero shot prompting, because you are it can still come back with an answer, but sometimes it may not be accurate. So to improve the accuracy, you can also give an example. So here we gave two examples. So this is called a few shot prompting. So with this example, the language model can use those two to do in-context learning and then come back with the correct answers. Okay. Another, I want to touch on one more patterns most of the customers use when they use the foundation models are retrieval augmented generation or RAG. So in this case, so the large language model is like a more generic model. It may not have any information about your corporate data. So what we do, like whatever user entering, and then we'll take the prompt and queries, what they're asking for. We'll take the query and then search against the corporate database. It can be a Kendra or any kind of knowledge base, any kind of vector database. You can search and then get the relevant information and take the relevant information and then send that to the large language model. It's like the enhanced context will be the data coming from your customer's database. And then the model will create a customized response based on the enhanced context, and then that will be sent back to the user. So this is like one of the design pattern to use foundation models along with your own data. So given that context, I'll hand over to Alak to talk about how AWS tools can help with getting started on generative AI.
Thank you, Suresh. So having talked about what is generative AI and the different use cases, and we talked about the foundational models, let's talk a little bit about why AWS for generative AI. So how can customers quickly start using what's available today and what's likely coming tomorrow in the space of generative AI and start to begin using the foundational models for their business? And they can drive the productivity and also transform their offerings. Right, so at AWS, we have 5 important considerations that can help you to quickly build and deploy generative AI applications at scale. So let's jump into those considerations and see how AWS can help. So first, AWS offers a wide selection of foundational models, both that are built by our leading AI startups and also Amazon provided own models as well. So you have that option to choose the right model that best fits your use case. So second, it should be easy for you to simply take the base foundational models and build a differentiated applications with your own data, right? And in that process, it's important that your data stays safe, secure, and protected. And you must have full control of your data on how your data is being shared and how your data is being used. So with AWS, none of the data is used, none of the customer's data is used to train the underlying models. And so the data is also encrypted and it does not leave the virtual private cloud. You can be assured that the data is going to be private and confidential within AWS. So next, whatever it is that you want to use your foundational models, right? Whether you're running those models or training them or customizing those models. So it's important to have the best performant and cost-effective infrastructure that is purpose-built for machine learning. So with AWS Inferentia and Trainium, which is our purpose-built machine learning accelerators, they are built ground up by AWS that can help specifically address training and inferencing on the cloud. So next, it's important to have the ease of use, right? So quickly, customers want to be able to integrate the foundational models into their applications and with some of the controls that they are already familiar with. So for example, instead of with using the AWS for generative, with the AWS's generative AI capabilities, it should be easy for you to, take, instead of sending the data to the model, you're able to bring the model to your data. So lastly, building generative AI powered solutions. So with the sample solutions that combine the AI services and some of the foundational models provided by the leading startups, we're able to create that impactful generative AI applications for solving your customer problems. So having talked about why AWS, why AWS, we're going to cover some of the generative AI capabilities that AWS offers. So first, we have Amazon Bedrock. You've probably heard about it a lot recently. So Amazon Bedrock is a fully managed service that provides access to the foundational models that are both provided by the leading startups and Amazon's developed models as well. And just by using an API call, you're able to get access to those foundational models. Second, we have the AWS Trainium and Inferentia chips, which allows you to do training and inferencing on the cloud with the best price and performance factors. So third, we have Amazon Code Whisperer. So Amazon Code Whisperer is our AI companion tool, which helps to generate code. And it also improves the developer's productivity and by providing a secure code as well. So lastly, we have SageMaker. So for customers who are intending to have the full control over their infrastructure and deployment of the models. So SageMaker is obviously available today, and its core value proposition of machine learning can be directly extended to generative AI capabilities as well. So we have JumpStart, which provides a foundational model hub, which provides access to some of the publicly available foundational models and also the proprietary foundational models as well. So having talked about the various generative AI capabilities, I want to show you the AI and ML stack and show from the ease of use and the complexity of where these offerings fit in. So think of this as a 3-tier stack. And at the very bottom of the stack, it's intended to provide a self-managed experience for customers who are very deep in machine learning, and they're looking to build a foundational models from scratch. So we have AWS Inferentia and training in that layer. Now, next for the set of customers who are looking to get a managed experience and they are looking to develop a generative AI application, but they simply want to make an API call to the foundational models that are built by the other providers. SageMaker is a best fit there, and SageMaker JumpStart provides you access to those foundational models, which you can simply put together in your generative AI application and develop that quickly for you to get started. So at the very top layer is our AI services that are intended to provide a completely serverless experience just by using an API. So Amazon Bedrock and Code Whisperer fits in that layer. And I'd say that's sort of the easiest way to get started to create a generative AI application. So in that layer, you do not have to worry about even deploying an endpoint, managing any of that infrastructure. So the customers can really focus on what is important to their business, and AWS will take care of all the undifferentiated heavy lifting for you. So let's dive a little bit into Amazon Bedrock. So Bedrock is the easiest way to build and scale generative AI applications Some of the benefits that Bedrock provides. The first differentiator in the market is that it helps to improve the productivity. So by providing a serverless experience, for example, say you're looking to develop a text-to-text application, right? You're simply having to provide text as an input, and Bedrock will invoke the large language model behind the scenes and just provide the text as a response back on an API call. So the next differentiator is the wide selection of foundational models that's available for you to use in your application. So thirdly, Bedrock also allows you to customize your own data on top of the base models that can be accessed through the Bedrock. So next, it's also important to call out that we have all the security capabilities that are built in. So your data is encrypted, it doesn't leave the virtual private cloud, and it provides you the confidentiality that you require for your own data. Lastly, using the AWS tools and capabilities that you're familiar with, it's easy for you to quickly put together a generative AI application. So what does Bedrock support? What sort of foundational models are now provided, right? Let's talk a little bit about the foundational models provided by Amazon. So we have Titan Text and Titan Embeddings. Titan Text large language model is used for use cases like text generation, text summarization, open-ended Q&A, and if you're looking, for example, to create a blog post, you can leverage Titan Text for such use cases. And then we have Titan Embeddings, which takes text as an input, and it can create embedding as an output. And this is useful for scenarios that Suresh previously covered, like the retrieval augmented generation sort of use cases, and also semantic search use cases. So what's really powerful there is that being able to create those embeddings when you're leveraging these large language models for search and personalization sort of use cases, you can really get a contextual response rather than simply doing a word matching. And then the leading AI startups like AI21 Labs providing Jurassic 2, which is really helpful when it comes to multilingual use cases. And we have Claude provided by Anthropic. If you're looking for some sort of chatbot and dialogue-based scenarios, Claude's been very powerful. And if you're looking to create images using text, Stable Diffusion provided by Stability.ai is another use case there. So with Amazon's Titan, we talked about Titan Text and Titan Embeddings. The important thing that I want to call out here is that Titan supports the responsible use of AI. So by able to reduce the inappropriate or harmful content, either in the data set that's being used for training, or if there is a user input that may have some sort of inappropriate content, they'll be removed. And similarly, the output of the model has any sort of hate speeches or any violent content, those will be filtered out as well. So these are the different, the AI startups and the models that are provided that can be leveraged within Amazon Bedrock. And Bedrock also provides the ability to fine-tune and customize the models using your own data set. So next, we have Amazon AWS's Trainium and Inferentia. So these are the purpose-built machine learning accelerators. They're the silicon chips that are built ground up. The important thing to call out here, AWS Trainium can provide up to 50% savings on training cost, and Inferentia 2 provides up to 40% better price performance than the other comparable EC2 instances. Next, we're going to talk about Amazon Code Whisperer. So Code Whisperer is an AI coding companion, and it's been trained with billions of lines of code, both by Amazon and open source code. So the developer productivity can be enhanced and freeing up the developer's time to really focus on some of the things that's really important for the business facing use cases that they can focus better. So it's already available, generally available, and it's free to use for individual developers. So I definitely recommend that you check out Amazon Code Whisperer. It's natively integrated in our Cloud9 IDE and also AWS Lambda console. It's also available as an extension in Visual Studio and IntelliJ IDEs. And one of the things that was found out during the preview that Amazon ran, it was found to be 27% more likely to complete tasks successfully. So then also average of 57% faster than who did not use Code Whisperer. Code Whisperer also supports the programming languages like Python, Java, JavaScript, C#, and 10 other programming languages today. And it can take prompt as an input. So for example, I should be able to pass a prompt saying, hey, parse me the CSV file and extract the second field and sort by descending order and put together the unit test, right? So Code Whisperer can do that for you by generating full lines of code or function suggestions within your IDE. So lastly, we have Amazon SageMaker. So as I mentioned before, a SageMaker's core value proposition that it provides on machine learning is directly extendable to generative AI capabilities. So for example, let's say you're creating a generative AI application with a model that is involving billions of parameters. Most likely you're going to be needing some sort of a distributed training libraries, right? So, and with SageMaker distributed training libraries and model parallelism, it provides a very powerful way to train and deploy those models and create a generative AI experience. And something important to call out here is our partnership with Hugging Face. Hugging Face is a model provider, and the open source models, foundational models, and other models are available for you to bring to SageMaker for both training and deployment. So having talked about SageMaker, what does JumpStart provide? Right, so SageMaker JumpStart can be leveraged for self-managed access. So you have ability to access the publicly available foundational models provided by Stability AI, Alexa, Hugging Face, and also the proprietary models provided by our leading AI startups like AI21 Labs, Lighton, and Cohere. So there are 3 different ways to use the foundational models within SageMaker JumpStart. So one, you can leverage SageMaker Studio using a one-step deployment process. Second, if you're looking to do some sort of a fine tuning, you can leverage SageMaker notebooks. And lastly, our AWS management console on our SageMaker console page. On the left-hand side, if you go to JumpStart, you can get into the foundational model hub through the JumpStart foundational models page. So what is compelling with SageMaker JumpStart? It provides you a one place where you're able to browse both the publicly available and the proprietary foundational models. And you can start doing some experimentations on the UI interface that we're providing on the SageMaker JumpStart. And then you're also having the ability to customize those foundational models, some of the select customized models, and then deploy that to a SageMaker endpoint. So with that, I want to leave you with some of the useful resources that can help you get started with your generative AI journey. So do check out our AWS Generative AI webpage, our announcement blog post, and the video from Werner Vogels, our CTO, that's explaining generative AI. And I've also included an interesting blog post which showcases the real life example, what we call as an image to speech technology that we built. It's intended to help the visually impaired to be able to hear an image. So an image, you'll feed image as an input, and the caption of the image will be described back to you in a human sounding voice. So check out a blog post on that, and it also includes a reference architecture if you're interested. And with that, that kind of takes us to the end of the presentation. Thank you so much. And you can find our LinkedIn profile and our email addresses over here. I don't know how we're running on time, but if there are any questions, feel free to reach out to us in the hallway.
Yeah, thank you. Thank you all for listening to us. Thank you for all the community leaders for organizing this event. I think we're almost run out of time. So yeah, feel free to reach us in the hallway or during the happy hours.